Okay, so welcome back. This will probably be the last of the tutorials that go over the fundamentals for thermal expansion. What we're going to be talking about this time is just some more detailed, advanced information about logistics, and then also upgrades for machines. So to start off with, I just wanted to talk about flux ducts and some more miscellaneous data about them. We've actually already seen this before, but when we have a flux duct network that can give power to two different machines, it actually splits them evenly. So if I come over here to this one steam dynamo that's just outputting into this one empty energy cell, and I take one piece of planks and I put it in there, it'll make 3,000 redstone flux directly into this one recipient. But if I come over here, which is almost the exact same setup, but it goes into two energy cells, you will see that each one will receive 1.5 kilo redstone flux. Another thing that you might want to know is that if you're used to immersive engineering or the old Industrial Craft 2, that in those energy networks, there's actually a fall off where if you try to bring energy through too long of a network, it starts to lose energy ambient to the environment. This does not occur in thermal expansion with the flux ducts. There's zero power fall off over distance. Right here I have a demonstration where I have basically this, but with a 151 leadstone flux ducts in between the dynamo and the energy cell. And you will notice that if I go ahead and put some water in this, and make sure this is empty first, yeah, okay. So if I put water in that, and then I put a plank, we will get, eventually, well, not even eventually, it actually happened instantly. We got 3,000 kilo redstone flux at this end. I also did a test that had a little bit of inconclusive data. I wanted to check and make sure if... I wanted to check and see if the flux ducts were capable of bringing energy through unloaded chunks. So I have this set up once again, the steam dynamo, and a energy cell at 500 meters away from this location. And this steam dynamo is kept chunk loaded over here, and the energy cell is kept chunk loaded over there, but there's definitely some conduits in between that do not get chunk loaded. So if I were to teleport to the other end, you will see that unfortunately the power is not actually able to transfer through the unloaded chunks. That, or there is actually a limit to the amount of the distance that energy can go through ducts, but I don't think that's the case. I think they just can't go through chunks. However, I did find that if I go to here, which is about 230 meters away, you'll see that there is energy here, but if I keep walking, there's not energy here. There's not energy here, but then if I keep walking backwards, there's not energy for where there was energy, and then it's there, and if I follow there, there's energy here now again, and then there's no energy, and I walk backwards, and there's no energy where there was energy. So, yeah, it seems to either be getting really glitched out after about 230 meters, that or there's something wrong with it trying to go through unloaded chunks. I don't have the answer, and I've looked around through the internet and tried to find the answer. If someone does have an answer to that, I'd really appreciate seeing it in the comments section. And then there's also one thing that I never got a chance to mention about energy cells, and that's that these two buttons over here. So the basic energy cell is actually capable of taking in 1,000 redstone flux per tick and 1,000 redstone flux, and it's able to output 1,000 redstone flux per tick. This means that you can actually throttle the amount of energy that's capable of coming into this energy cell, and you're able to throttle the amount that comes out of it. So I have two energies. So this energy cell is full, and these two energy cells are, empty. So if I go ahead and throttle the output amount to 50, and then I go ahead and set it to output from the top, because this is hooked up from the top, you'll see that the energy cells are actually receiving energy extremely slowly. And if I were to decrease this energy cell's input rate down to 50, and change this back up to the normal output rate, you'll see that this energy cell is now gaining energy much faster than this one is. It's not always a very useful thing, but in some circumstances I've seen it be useful for looping energy. Okay, so I realized I didn't really do a good job of explaining why throttling the output and input of your energy cells is actually a good idea sometimes, so I decided I would re-record a segment demonstrating that. So the first example of where that would be helpful is if you have two sections of energy consumers inside your factory, two sections of machines, and one of them uses significantly more power than the other. For example, right here I have one pulverizer which just uses 20 redstone flux per tick set up to this battery. And over here, I have 5 magma crucibles, which each use 40 redstone flux per tick. So we have 200 redstone flux per tick being used over here, and 20 being used right here. So ideally, we prefer to have more energy going to this side than half of it being split off to go to something that only needs, like, only a tenth of it. Because, otherwise, if we just connect it, if we were just get rid of these batteries and replace them with conduits, flux ducts, then half would be going here and half would be going there, and that's not really the split that we want. So you put energy cells in the middle, and here we throttle the input speed down to 20, and the output can just stay whatever it needs to be. And for the record, these controls, these pluses and minuses here, you can hold down Shift and Control to modify the amount that you increase and decrement by. So right now I'm holding Shift, it goes to 1000 by 100. And if I hold Control, it goes to 5 by 1. So that's how you can get definitive control. And then by right-clicking and left-clicking as well will change the amount that you change by. So yes, we throttle this down to 20 redstone flux per tick, and then this can just stay throttled to, however much we want. We want to send the majority over here anyway. So if I go ahead and flick all of these on to allow power to send through them, you can see that this is filling up pretty slowly with power. And this is, these are filling up pretty quickly with power, despite the fact that it's being sent to 5. And usually whenever you're doing this method, you want to make sure that you give your, you want to make sure that you give your machines a little bit of time to actually fill up with power. In fact, I could actually undo the throttle here, let that fill up extremely quickly. Okay, and then I can bring it back down to, I can bring it back up to 20. There. And now this battery will only ever take as literally the exact amount that it needs for this pulverizer to run. This is also an extremely helpful thing in this quite classic example of an early game renewable energy source. So the thing that's going on here is that we have a fractioning still, and the fractioning still does what it says. It refines fluids into other products. And it has a tank of resin. This is a tree resin. And you can either get resin by putting an arboreal extractor next to a tree, or you can get it by putting this resin funnel augment onto a sawmill. But when you put this resin into a fractioning still, it will process it into tree oil, and tree oil can be combusted in a compression dynamo, along with a coolant type, to make power. The quirk with this system is that the fractioning still itself actually takes 20 redstone flux per tick to work. So part of the energy produced by this system needs to actually go back into the fractioning still. Now, currently, the way that we have it means that the 50% of the compression dynamo's output will go into the fractioning still itself, but this only needs 20 redstone flux per tick to work. And you can see that this specific compression dynamo that I've upgraded outputs 80 redstone flux per tick. We don't really need 40 of that going out to the fractioning still, so we could probably throttle that so that the majority of it goes into the energy cell. So what we can do is we can go right here, put down an energy cell, set the output to the back so that it actually goes through. And then I'm going to turn on redstone control just for the sake of demonstration. And now we just want to make sure that only 20 redstone flux comes out of that so that this fractioning still gets the bare minimum that it needs to stay on. Okay, now if I were to just give this a jolt of energy by putting a creative energy cell on it, you could give it a jolt of energy by just putting any combustible fuel in there, but I'm just going to do it this way. Okay, that should be enough, I think. See if that was enough. Okay, hang on. It actually needs I actually need to give it a little bit more. It just needs enough energy to get through its first process. So I'm actually going to, once again, increase the RF a little bit. Okay, so you can see it's cooking along pretty nicely. So now I'm going to drop the RF per tick down to exactly what the fractioning still needs. And it outputted some tree oil into the compression dynamo. And now you can see that the energy inside this cell is actually remaining constant because it's taking in 20 and it's outputting 20 to keep the fractioning still on, and the excess is going into here, which is perfect. That's exactly what we want. This loop is only having the exact amount of energy that it needs to stay on, which is perfect. Okay, so we're done talking about energy. Let's move on to fluids. And the fortunate part about this topic is that fluid ducts are almost pretty much identical to flux ducts, at least in their properties. So you can see here I have a portable tank set up to a fluid network with a portable tank receiving on the other end. And I'm just going to demonstrate that, fluids don't actually need any like pressure system. They don't need to be pressurized, and they're able to go in pretty much all directions, up, down, forward. We've seen that they can go left and right already. So if I put a water bucket in here and switch the portable tank to output mode, you'll see that it transfers pretty much all the liquid almost instantly, which is pretty good. There are different types of fluid ducts, but only one of them actually changes the transfer rate. The one that we're used to, which is just called the fluid duct, can transfer most liquids, but not if they're very hot or very cold. So they can't transfer lava or gelid cryotheum. The hardened ones can. There's also one called superlaminar fluid ducts that transfers fluids at pretty much an infinite rate. So they move pretty much like instantly. And then similarly to energy, fluid is also capable of splitting itself between two different recipients. So if I put water into this bucket, it will flow to both of these two recipients if I set it to output mode. Although there is one little quirky thing about this, which I don't know if it's something about the setup or it's just kind of bugged in the installation that I have, which is that if I pick up this portable tank and look at the contents, you'll see this one actually has 505 millibuckets of water, and this one has 495. Which is strange because I put 1,000 millibuckets into the, output tank, so you would expect them to both have 500. And these paths are exactly the same, so I'm not really sure why there's like a little discrepancy there. But it might have something to do with just like tick rate. It's obviously not a very big discrepancy, so you don't have to worry about it, but I just thought I'd point out that it's there. So I left kind of the best for the last because item ducts have the most complex logic to how they move through ducts. Of all the logistics types. So to go over things, item ducts will always prioritize going through the shortest length path first, and they will only transfer through to valid inventories. And invalid inventories would be a container that is full, or the incoming item to that container would be incompatible. So if you're used to buildcraft item pipes, where you would have that problem where pipes would try to pipe into full containers, and then they wouldn't be able to, and then they drop onto the floor and despawn your shit. Sorry, despawn your items. In thermal expansion, something won't even attempt to output into an item duct if there isn't a place for it to go. So you don't have to even worry about that problem. So I have this yellow chest that's going to be outputting into an item duct, and we have 3 possible places for it to go in this demonstration, and it'll start outputting when I flip this lever back here through this reinforced servo. And inside the output chest, we have just a couple of anvils. So there's 3 places for it to go. The first one is a pulverizer, which is empty and powered. It's being powered by this creative energy cell, which just outputs, infinite power for the sake of demonstration. There's also a strong box that is available, but it's full. And then there is this last strong box that is empty. Now, according to the rules, it is going to try and put something into the pulverizer first because it's the shortest length path. But unfortunately, anvils can't actually be placed into a pulverizer. You can see I can't actually do that. So it's not going to try and put it into the pulverizer. Next, it'll try to put it into the strongbox, but the strongbox is full, so it won't try to put it in there. And the last place to put it is this empty strongbox, which is the furthest path away. So if I flick that open, you'll see an anvil flip into this strongbox. Now, if I were to put an iron ore into this box, and for the record, when a servo pulls something out of a box, it always goes from top left to right, and then down, as you would, read like letters on a page. So this iron ore actually has two places that it could go. It could go to this strong box with valid space, or it could go into this pulverizer. But since the pulverizer is closer, it'll actually be sent to the pulverizer. If the pulverizer was actually further than this chest, it would be sent to this chest, so just keep that in mind. Also, if this pulverizer was like working on a stack of iron ore, and we tried to put tin ore into it, so we have the tin ore in there, you'll actually notice that since the tin ore wouldn't actually be able to fit into this machine because it's working on iron right now, it'll just go into the other valid place, which is the strong box. Okay, so moving on, talking about the conversation of item ducts, I just wanted to clarify that when I say shortest length path, it actually counts the amount of ducts that the item would have to go through to get to its destination. So in this case, we have the output chest, which is just outputting some nether stars, and there's two possible recipients. The first one is over there, the second one is over here. And even though this chest is physically closer to the output chest, it has to go through more item ducts in order to get there than this path, which is, the chest is actually like displaced further away from this one. So since this one has less duct work to go through, it'll actually go to that one. And we can see some nether stars have been added to that one. Now, you don't use these too often, but they are extremely helpful when you do wind up using them. And these are dense and vacuum item ducts. You can get a hold of these by just crafting them. You can see if I type in dense item, we see dense item duct right here, and there's also an impulse item duct version, which I'm using. For the record, that's why these item ducts are yellow. It's because they're impulse item ducts, and impulse item ducts are just faster. Items flow through them significantly faster than normal item ducts. So anyway, you can tell that this item duct is a dense item duct because it has these red dots on it. And what they do is they artificially increase the path length of this block. So right here in this network, I have two chests and one output. The output is right here. And in any normal circumstance, we'd expect it to go to this one because it is closer. But this dense item duct actually considers itself to be many more times blocks long than just a normal item duct. I believe the version of thermodynamics for Minecraft 1.6.4 said somewhere in its documentation that the dense item ducts are worth 1,000 item ducts of length. So I'm going to assume that that's true, but I've not been able to confirm that recently, so that might not be completely true. So when this network is looking for somewhere to go, it's going to start here and go into the first item duct for a length of 1. And on this side, it's going to go 1, 2, 3, 4, 5, 6 into the chest. And for here, it's going to start 1, and if we go left, it's going to start 1, and then be 1001, and then 1, for the path length to get to this chest. So obviously it's going to prefer that chest over there. Okay, and now there's also something called a vacuum item duct, which basically does the opposite thing. The vacuum item duct subtracts 1000 from the path length in this direction. So we have two places to go. The first one would be 1, 2, 3 into this chest, which you would expect it to normally go to in any normal circumstance, but we go this way, 1, 2, 3, and then negative 996, 900, negative 995, and then into this chest. And obviously it's going to go for the one that is, far into the negatives. Okay, and that's pretty much it for ducts. There's actually just one more thing that I wanted to mention as a tip. There is something called signalum plated ducts that you can use to transfer redstone flux and items at the same time. You can see in this setup I have an output, which is an output chest, which is outputting iron ore into this network through an impulse item duct. And I also have a energy cell, which is outputting, energy, or it will start outputting energy when I flip this lever, because the redstone control for this is set to high. And it does that through a flux duct, and these two meet up inside of a signalum plated impulse item duct. Damn, try saying that a couple times, yeah? And it's actually going to be able to accept the redstone flux and the item and push it into the pulverizer. So I can turn this on, I can turn this on, and then I can come over here to this pulverizer and see that it is getting charged, and I just have to set the face on the back to accept input. So I can switch this over to blue, and we can see that iron ore gets sent to it, and it is staying charged, and it is staying saturated with items to pulverize. Okay, and now on to the last segment. I wanted to talk about upgrades. And now every functional block in thermal expansion is capable of being upgraded, at least any of them that, perform an operation. Every time you upgrade a machine, it goes up to another tier, and the tiers go basic, which is the one that you get when you craft the machine and put it down. Then there's hardened, reinforced, signalum, and resonant being the highest. And there's also creative tier, but that one you can't actually get in survival mode. It's just for testing purposes. So machines, energy cells, and dynamos can all be upgraded, and each of those three types receive a different, bonus when they're upgraded. For machines, such as the redstone furnace and the pulverizer, their operation speed is faster, they consume redstone flux faster, and they get a bigger redstone flux buffer. For energy cells, they just get a significantly larger redstone flux buffer, and their input and output maximum speeds are increased. So remember I showed that demonstration over there with throttling the speeds. They actually get a bigger output and input speed when they're upgraded. And the dynamos just get a flat out operation speed increase. So I never got to mention this in the first episode, but machines actually, the operation speed of a machine is proportionally linked to the amount of redstone flux it is consuming per tick. So this means that if your power network is really dry on redstone flux, you'll notice that your machines are working extremely, extremely slowly. But we can also use machine upgrades to increase the amount of redstone flux they consume per tick, and thusly increase their operation speed. And also as they get upgraded, they receive a larger redstone flux buffer. So if I come to the basic machine, we can see that it has a 20k redstone flux buffer and uses 20 redstone flux per tick, which we can see here. And then we can also see here with its maximum power usage. And then per upgrade that we get, we're going to see an increase of about, we're going to see actually exactly an increase of 10,000 redstone flux buffer and 10 redstone flux per tick. There and there. And you can see the upgrade, it upgrades pretty much linearly per upgrade. And you'll see that happen for pretty much most, this is pretty much a repeating pattern for most machines. They will upgrade with a flat increase every single upgrade, up to being about 3 times better. So if I come over here and I put a piece of iron ore into this basic pulverizer, it's going to take a pretty significant amount of time. I think it's the same amount of time that a normal Minecraft furnace uses to smelt something. Now I come over to the resonant one, it's going to take roughly about 3 times less time. Now, also something that's really cool is as you upgrade machines, at least to the hardened tier or higher, you start unlocking augments for them. And augments are essentially perks for your machines. If I go into my JEI menu and I do @thermal and then space augments, sorry, not augments, just augment singular, you can take a look at all of the available augments for your installation of thermal expansion and modules. Some of the modules, if I hover over them, you'll be able to see what machines they apply to. Some of them apply to all machines, whereas a couple of them only apply to, just dynamos. But most of them just apply to a single exact machine. Like this one only applies to the fractioning still. Augments usually either make one element of the machine better, or they unlock some kind of new processing type, some new recipes for that machine. And most of them will do so at some kind of drawback. So you can see this one called the reflux column allows the fractioning still to have a greater conversion rate for, turning fossil fuels into fuel. But as a drawback, it uses additional energy every time it performs an operation. As another example of one of my favorite augments is this ignition plugs for a compression dynamo. And what that does is it greatly increases the power generation of the dynamo, but it can only specifically use refined fuel now instead of other liquid fuel types. So in order to upgrade a machine, what you need to do is you need to craft these upgrade kits. The lowest tier one is a hardened upgrade kit. And once you have the upgrade kit, you can go up to a machine. And as long as the machine tier is one lower than the upgrade kit you're trying to use on it, you can upgrade it to that tier. So I have a hardened one, and I'm going to use it on a basic machine to bring it up to hardened. And now I can, if I take a look at the machine now, it has some slightly better stats. And I'm able to actually put an augment slot in it too. Basic machines are not allowed to have augments in them. You see it says I need to upgrade the machine in order to do that. And I can go from hardened to reinforced to signal them to resonant. And you'll see when I go up to resonant, I now have 4 augment slots. I don't think you'll ever really use all of those augment slots. Usually you wind up putting like 1 or 2 on a machine at a time. But it's there for you if you want to. And then for energy cells, as you upgrade them, they get a larger redstone flux buffer, and their input and output rates get higher. So if I come over to this energy cell, this basic energy cell, you see that it has a 2 million RF buffer and can output and input 1,000 redstone flux per tick. And this resonant one, if I run over to it, has a 50 million redstone flux buffer, which is, many times more than the 2 million that the other one has. And it is capable of outputting 25,000 redstone flux per tick, as well as inputting. One thing left to mention is that the flux ducts actually have their own individual transfer rates if you hold down shift and look at them. The basic one that we've been using this whole time has 1,000 redstone flux per tick. And as we go up, you see the hardened one has 4,000 up to 25,000 for resonant. Now, basically what happens is if you try to put a higher transfer rate into a conduit that can't really handle it, it gets bottlenecked down to the level of the flux duct. So for instance, this energy cell is capable of outputting 25,000 redstone flux per tick, but if I were to try and feed this into a leadstone flux duct, which only has 1,000 redstone flux per tick max, then this will only actually be able to output 1,000 redstone flux per tick because it is bottlenecked by the leadstone flux duct. Okay, and that's pretty much everything you need to know to mostly everything inside of thermal expansion. You can pretty much explore the rest and find out the rest on your own. If you do get stuck, a really good place to go is the COFH wiki page for thermal expansion, because they have the most up-to-date information on everything inside the mod pack. I will leave a link to that in the description, so happy hunting with the rest of the mod.